can you design a rate limiter for us? Hi, everyone, and welcome to another mock interview with Exponent. Today, I'm here with Hozefa, who's been with us before, but would you like to introduce yourself for anyone who's seeing you for the first time?
Yeah. Hi, everyone. I'm Hozefa. I'm an engineering manager at Meta.
Nice to see you again, Hozefa. Today, we're going to do a system design mock interview. And our question for you is, can you design a rate limiter for us?
Yeah. Cool. So just to get started, a rate limiter is a system that blocks a user request or allows a certain number of requests to go through in a specified period of time. Why do we need rate limiters? We need rate limiters to prevent DDoS, which is denial of service attacks. It helps to reduce costs for the company because they kind of need less servers to manage their load, and it prevents overload for the system. So uh, uh, some kind of an attack can actually hamper the actual users of the system. So the idea is that any one particular user or set of users don't exponentially take up most of your computing power. That's why we would use a rate limiter. Some questions I would have on the
Okay.
requirement side. We would want to implement a server side rate limiter.
Yeah.
And we could throttle the users based on like some kind of a unique identifier. It could be the user ID, the IP. I think the most common approach is using an IP address.
Why
Uh,
would you use that over anything else?
I think there's IP addresses is something that is always unique to users, and you can narrow down a set of users or a set of IPs which seem to be problematic. User IDs can kind of be faked. You can create new accounts, and then it's difficult to distinguish a good user ID from a bad one, whereas it's more easier on the IP side.
Okay.
And I think we need to inform the user once we do block them. So the HTTP layer has a built-in protocol for that. So we send the user from the server, we send a 429 status response code back to the client, informing that they've been kind of throttled and they've been blocked. And I think we should obviously have some kind of a logging mechanism on our side in order to do analysis on the traffic patterns, what IPs we are getting, any retrospective we need to do over the period of time based on the traffic that we have. Next thing I would want to, sorry, go ahead.
No, that's fine. Go ahead.
Yeah, the next thing I want to kind of talk about is in the rate limiting space is how would you rate limit a user, right? Identifying that we've identified a IP or a set of IPs that we want to rate limit. What is the technique that we would use to rate limit them? So there are many algorithms available to do that based on what you are trying to, or someone is trying to optimize for. I'm going to just kind of talk about a couple. So one is the token bucket system. This is basically a very simple implementation where to think of it as you have a set of tokens, and every request takes up one token. The bucket gets filled up at a constant fixed rate of tokens per second. So let's say, for sake of simplicity, you have the bucket getting filled up at the rate of 1 token a second, and as the requests are coming in, a token is getting used up. If when a request comes in and the bucket is empty, there are no tokens available at that time, we essentially are saying that we are going to block or throttle this request. So we, instead of forwarding the request to the server, we send the user back a 429 response. It's a very simple implementation. Obviously, there are downsides where if there are spikes in traffic, you would have a large number of users not getting the response that they want. So you would have to constantly keep tweaking the size of the bucket.
Yeah.
Another very popular system is the fixed window system, where essentially, given a time window, you would have a fixed number of responses available within that time window. Once those responses are used up, until the clock starts again, no request can get handled. So if you think of it like, let's say in a 10-second window, you have 30 requests that can be handled. In the once those 30 requests are used up in the 10 seconds, you have to wait for the next 10-second window to start before new requests can be processed. The downside to this implementation
Hmm.
again is that you could have cases where technically requests are coming in maybe towards the end of the 10-second and the start of the next window. So you could have a spike of requests getting processed very quickly, and then you have large spaces of time where no request can get processed, right? So you would have varying implementations of this algorithm, like there are sliding windows systems where, based on traffic patterns, you are constantly tweaking the window size and the counter in each window to best suit your needs.
Yeah.
Cool. Any questions so far?
Okay, so let's say that we are designing this rate limiter for a website like, let's say, Twitter. What would you choose in that case?
Right. I think was something like Twitter. We could use an adaptation of the fixed time window algorithm. Like I would use more of a sliding window where uh, we are not fixing the amount of requests per second, but we keep sliding them as time goes by. So if there is an extra request that are no longer used, we can keep sliding the window with it. So that way,
Hmm.
if there are spikes in traffics and if there are lulls, they can be handled well.
Got it. Okay. And is there like a limit to how much you can slide over for each of these windows?
Yeah, so I think all of those are configurations that you can set when you define the rules of the system. So I'll
Got it.
get into some of those details, like in the high level design. It's
Yeah.
basically you define like a rule engine which will determine what the size of the window is, how many counters do you need within each window, uh,
Hmm.
what's the sliding scale over there.
Yeah. Okay, let's get into that.
Sure, cool. So at a high level, the rate limiter consists of a few components. So as we said at the start of the recording, that we'll have a server side implementation, right, of the rate limiter. And one of the reasons we want to do this as server side is, on the client side, it could be easy for someone who has malicious intent to forge or bypass the rate limiter, right? Like if every client were to have an implementation of the rate limiter. So we would do this on the server side, so we have more control over it. So before the request uh, gets processed to our API servers or our web servers, there is a rate limiter middleware there. The next component we would need is some kind of a rule engine. This is where, as I was mentioning, right, that we would define what is the algorithm that we want to use, what are the rules that we want to use, like whether it's an IP or a user ID or geography, whatever criteria that we want to rate limit on. That's one um, engine that we need. And the other
Hmm.
part is we need a cache which has a very high throughput, because as requests are coming in, we need to write into the cache, right, that which IP is getting what request, right? So then we can read from the cache to see that, has this IP already gotten the request or not, right? So we can block if needed based on, let's say, IP. And then in parallel, we can have like a logging service, which is logging all this information for future uh, analysis.
Okay, that sounds
Cool.
like a good start.
Let me just draw some of the components out to kind of make it more easier to visualize.
Yeah.
Yeah, so we start off with clients over here. Then the next thing we would build out is our rate. So this is our API rate limiter. You have our top of that, you would have a rules engine. Right, so our rate limiter is going to use data from a rules engine, and then these are our API/web servers. So, like, to think of it, basically our API middleware is almost like a if-else statement, right? That if this is a success, the request goes back to our API servers, right? Whereas if it fails, then the request kind of comes back to the user. So if we are like blocking, we would send like a 529 HTTP code out here, right?
Okay.
So success, we would kind of go back, and then the server would respond back, and then eventually the middleware would kind of go back here. So you would get a 200 response over here. As I mentioned, another thing we would need over here is a cache. So you have a cache which has a high throughput. The reason for this cache is that the API, the rate limiter, needs to see whether a particular user, if you're blocking, let's say based on IP, how many requests have they already consumed within the given counter.
Yeah. Also, I think you mentioned this before. I think you mentioned it's a 429 HTTP code. I just want to make sure that you mean the same thing over here.
Sorry. Yeah.
Yeah.
Yeah. And then from here, you could essentially have a system where you're doing some kind of logging mechanism. And then this is, you know, from here, you could even kind of think about it as that you're putting in like some kind of a long-term storage, right? Where the data can be kind of analyzed and processed in however, whatever way you want. Another optimization, now that I think about it, is you could do is that the rules engine, essentially every time a request is coming to the API rate limiter, it needs to check with the rule engine that the rules have changed or they are the same ones. You could potentially build out a cache in the middle.
Yeah.
So you can have a rules cache where instead of calling the rules engine, the rate limiter would essentially first read from the cache and then directly kind of use that for faster read access, and the rules engine could would directly write into the cache. Yeah. So at a high level, this would be like a API rate.
Your rate limiter.
Yeah.
Yeah.
Like I just for, clarity, you could just kind of mention some of the requirements again, so that it's a server side. We can log based on IP, user ID, etc. And send 29 HTTP request on blocking and logging. Yeah.
Okay. So how would you modify this for a distributed environment?
Right. That's a very good question. So this system right now, is based on a single data center environment where all the requests are coming in through the same rate limiter and going through the same uh, set of web servers. In most big systems, we do have a distributed environment where there is more than one data centers. So essentially, what we would need is what would change essentially over here is that obviously we would have some kind of a load balancer. So if you would think about it that oops, I will just move the clients a little further away. We would have some kind of a load balancer over here, right? So the load balancer now is managing requests across multiple servers, multiple data centers, right? And then over here we essentially have like multiple implementations of your rate limiter, right? Where every data center has their own implementation of this middleware. I think what kind of remains constant or needs to scale horizontally in some sense is your cache, that you need one common cache across a distributed network. Whereas if you have different caches, then essentially you are rate limiting per data center versus rate limiting across the globe. So you would need to kind of have one shared cache across all data centers. Now you could essentially look at different configurations where you can have like a one read cache and a one write cache, and then how do you sync between the two of them, or have one common read write cache which is shared across all data centers.
Yeah. Okay, that's fair. And then all your implementations of your API rate limiter, will they also read from the same cache? The rules cache?
The rules cache, yes. You could technically have, if needed, different multiple instances of the rules cache, because in theory the rules don't change that often, right? Where you wouldn't want to change a rule very often or multiple times in a day. Rules generally are set and they'll persist over a period of time. So they need not be kind of distributed. They can again be at a few places, and the rate limiters can read from there.
Is there a situation in which you would want to have different rate limiters for different geographies?
I don't think so. The reason is that if you would end up doing that, you would potentially put yourself in a vulnerable position, because then essentially if people were able to mimic where their request is coming from, you can essentially end up with kind of bypassing the rate limiter logic itself, right? Because if people starting using a VPN or something, then you could kind of essentially blanket where you're coming from. So you would want to have a consistent set of rules across the world, so that it's easier to kind of manage and throttle users.
Yeah, I'll just set my VPN to some country that doesn't use Twitter at all and try and scrape their website.
Exactly. Like if you have like, for example, a different set of users for US versus Asia versus Europe, right? Like people could try to circumvent that in a number of ways.
Yeah. So let's say put yourself in the shoes of the user for a second. Let's say that you've been rate limited. Maybe you don't have any malicious intents. What strategies are you as a user going to use to circumvent that?
Sure, that's a very good question. I think there are a few things as a user you could do that does not have a malicious intent, right? First thing I think is whilst you are integrating with some of these API clients, right? So let's say you are integrating with something like a Stripe, where you want to integrate with their payment APIs. You would want to know of what their rate limiting criteria is, and what is your traffic patterns, right? Like let's say if your traffic patterns are exceeding their baseline rate limiters, you would want to kind of, they'll definitely have plans to kind of upgrade you, right? So you want to make
Yeah.
sure that you are in the right tier uh, uh, for your vendor that you are using. The other thing you could do is, let's say you suddenly, for some reason, your system is getting a whole bunch of traffic, right? Is handling those kind of errors gracefully yourself. So when you get a 429 response from the server, you are able to handle that and show an appropriate error to the client, saying that try after some time. Or you could also build some retry mechanisms within your system yourself to try after like a few seconds to see if the request is then going through. So these are the
Yeah.
few things you could do as a user to kind of prevent yourself from getting blocked.
Okay. I think this is a good place for us to stop. Thank you so much, Hozefa. Any thoughts that you have post the interview?
No specific thoughts. I think again, like rate limiter or any kind of system design interview is a very open-ended question. There are n number of
Hmm.
ways to solve this problem. I think a lot of big companies, like I mentioned, Stripe, Amazon, Twitter, Facebook, all of them have very different way implementations on how they address this problem. And the idea in the system design interview is just to kind of think through what some of the requirements are, what the constraints are. Uh, it need not
Hmm.
be the exact solution that any of these companies use. They would have taken months and years to kind of come up with the
Yeah.
solution, and we don't expect a candidate to do that in like 45 minutes to an hour working by themselves.
What? You're telling me I'm not supposed to design Facebook's entire system in just one 45-minute interview? That's ridiculous. No hire. Lovely. Thank you so much, Hozefa. I'm sure this is going to be very valuable, and it was great having you with us again.
Yeah, thank you.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video is valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.